Hi and welcome to yet another video from Physics for Students. And in this particular video what I'm going to show you is that how to solve an integral equation. Obviously it would be a 4 integral. So say for example if you get a kind of an equation like this where there are 4 integrals, so you can call it as a quadruple integral equation or whatever. But before going ahead with this type of equation, what I would like to draw the attention of the viewers is that you can see there's a kind of a symmetry in this particular equation. So you see that on the left hand side all the integrals goes from the value from 1 to 2. On the right hand side you can see a kind of a differential equation which has got all the values of d's ranging from 1 to 3 and 4, and in the middle there is a numerator and a denominator. The numerator contains a minus sign, except that all the things are more or less equal. It contains a kind of a symmetry. So we can use this kind of a symmetry in order to solve this equation. So let us go ahead and find how we can do this. So first what I'm going to do is that I'm going to assume I equals to this entire equation. Then I'm going to take I sub 1 equals to this, taking the numerator as x1. I take I sub 2 taking the numerator as x2, and I sub 3 as the numerator x3, and I sub 4 as the numerator x4. Now note that in all these cases what I have noted right on the right hand side of your screen is that all are equivalent. So it doesn't matter which numerator variable has the minus sign. So the position of the minus actually doesn't matter. However, we have taken x1 on the numerator, so all the denominators have got a positive value. Now, so further what we can do is that we can take this as I equals to this, which you can see on the left hand side of the screen, and we solve it this and this and this. So we kind of get a value of I equals to ranging from 1 to 2 of dx4. Now because all these are quite symmetrical, which means that I1 equals to I2 equals to I3 equals to I4, which I can write as this, and from here we can deduce that I equals to 4 I sub 4 and I1 equals to I1 plus I2 plus I3 plus I4. So this is a kind of a deduction which we have done based on the symmetry. And from here what I can get is I1 equals to 1 upon 4. So we are going to take this value of I sub 1 equals to 1 by 4, and you can carry forward and take this value further. So what we see over here is that if I take the entire equation equals to I, so I can use the original equation, that is the x1, x2, x3 minus x4 as this, and from here I can substitute the value of 1 upon 4 which we got previously, and here I get the value as 1/2. So this is a kind of a answer. This is the real answer for the entire quadruple integral equation that we are trying to solve. Now what I will also try to show you is that I'm going to show an alternative method, because alternative methods are always good in order to flush off your mind or get an alternative answer. So because the structure of the integral looks something like this, so I can always assume I sub m is equivalent to this, and I can change the order of the integration which leads to this, and from there what I can do, I can write I equals to 2 I sub m, which results to this, and I can write 1/2 equals to this entire, and from there I get the value as 1/2. So you can see in both the cases the answers are both the same. It is 1/2 in the earlier method and in the alternative method. Now one important note which just came into my mind, I just thought to share it with the viewers, is that what if we trying to imagine quadruple integrals, because double and triple integrals not necessarily they always represent areas and volumes, because one can compute areas and volumes with single integrals in certain cases. So however, in an n-dimensional integral is generally representative of a n-dimensional volume, and we know that 2 integrals are generally refers to area, 3 integrals refers to volume, 4 integrals would generally refer to hypervolume. Now I understand this is really difficult to visualize, because a 4th integral would be something, it can be 3-dimensional space with 1 dimension and time. So maybe you are trying to integrate over space-time boundary, or it can be anything. It can be volume followed by hypervolume. So just a kind of a note, it is not easy to visualize what a 4th integral would be or what would be the 4th integral. most of the cases for physics in general relativity, we try to gather over something which is called a 3 integral followed by space time, and we are integrating time. So that's it. So this is a very nice small kind of a coincided video where I've tried to show how to solve this kind of a volume, this kind of an equation. I hope you liked it. So you can just like, subscribe, and Physics for Students. I will be trying to bring out this kind of long, difficult equations. I like to solve it for you. So stay safe and stay happy. Do subscribe, like, and please press the bell icon to get all the notification from Physics for Students. Have a nice day and have a great week ahead.